This is a common algebra problem that happens in calculus, and it's a little bit contrived, but it's common nonetheless, so I wanted to talk about it. I'm trying to factor this cubic expression, and I'm going to do it by guessing a root. In other words, a value of x that makes this equal to 0. Now, the whole idea behind this is that if it does factor, if it factors as completely as you could imagine, then it would factor into 3 binomial factors. I'll call them x minus r1 times x minus r2 times x minus r3. And then I notice that this whole expression would equal to 0 if x was equal to any one of these constants. So that means r1, r2, and r3 are roots of the original expression. And all we're doing here is turning this process around backwards. If we could guess a root, in other words, a number that makes this expression equal to 0, then x minus that number is going to be a factor. And then we can use long division to knock down the exponent of this thing to a quadratic. So the part that's a little bit contrived about these problems is that you aren't going to guess a root if it's some horrendous radical expression. You're just not going to guess it. So these are always set up to have small integer roots. So you just start trying stuff. And I would always start with 1 and -1, and then 2 and -2, and 3 and -3, and so on. So let me just try x equals 1 and see if it's a root. And that would give me 1 cubed plus 4 times 1 squared plus 1 minus 6. And that's 1 plus 4 plus 1. That's 6 minus 6. Aha. I found a root. I don't mean 0 factorial. I mean I'm excited. So that was a little bit too easy, so I want to explore some other options. And then we'll pick one of these roots to use for our long division. If I plugged in 2, that would give me 2 cubed is 8. Plus 4 times 2 squared, which is 16, plus another 2 minus 6. No, there's no way that's going to be equal to 0. What if I tried -2? -2 cubed is -8. 4 times -2 squared is positive 16. Minus 2 minus 6. So -2 and -6 is -8. If I combine that with this, I get -16 plus 16. That's 0 also. So we actually just, by guess and check, we found 2 roots. Ordinarily, you just stop after you find the first one. I just thought it was too easy. So I'm going to pick this one just because it's a more interesting root. I'm going to say x equals -2 is the root that I'm going to use to factor this thing. So if x equals -2 is a root, then x minus -2 is a factor. So I figured out x plus 2 is a factor of this thing. And that allows me to use polynomial long division, and I know this is going to divide evenly. If I divide out the x plus 2 out of this, then I'll find out this piece up here, what do I multiply x plus 2 by to get what I started with, and it's going to be quadratic, and then I can just guess and check the remaining factors. So starting from the highest power of x, I'm trying to match the x cubed here. So I'm going to put in an x squared into my guess, distribute that, and I end up with an x cubed plus 2x squared. Subtract that from the original polynomial, and I end up with 2x squared plus x minus 6. Again, just working from the highest degree down, I'm trying to guess the next piece to distribute in here to get what I'm looking at. And that would be 2x distributed to x plus 2 gives me 2x squared plus 4x. And I'll do the subtraction. My leading term dies by design, and I end up with an x minus 4x, which is -3x, minus 6. How do I get a -3x? I would put a minus 3 on here. Distribute that. I get -3x minus 6, and there is no remainder because I was guaranteed to have this divide evenly because I knew that it was a factor. All right, so what I've just figured out is that my original cubic expression could be written as x plus 2 multiplied by x squared plus 2x minus 3. And when I factor the quadratic part, that's a quick guess and check. And it looks like it's going to be a positive 3 and a negative 1. Just checking real quick, that's x squared plus 3x minus x. That gives me 2x minus 3. So that all looks good. And just to come back to the beginning here, I found an extra root just because I got lucky on my first guess. And I found that x equals 1 was a root, and that means x minus 1 was guaranteed to be a factor. So I knew that had to be there.